A HEPA filter is a highly efficient air filter constructed using a mat of randomly arranged fibres. To qualify as a HEPA filter, we have to meet defined standards of particulate removal. We've chosen to work to the requirements of an international standard known as 14644. As we've set about developing filters for use with our range of anaerobic and hypoxic workstations, I'm delighted to report that we can exceed the requirements of Class 3 of that international standard. As we've set about doing this, it's important also to understand that the standard requires that after a period of activity in the workstation, the particulate count must return to the same defined standard within 20 minutes of that period of activity stopping. We can comfortably meet that requirement.
Cell cultures and bacterial cultures are always valuable to the scientists working with them, but they may also be expensive or even irreplaceable. Prolonged incubation of cell cultures in a controlled atmosphere workstation may require significant movement of materials in and out of the chamber, and also regular manipulation of the cell cultures themselves. These operations can introduce a risk of contamination into the atmosphere, and this can cause a loss of the cells. This risk can be greatly reduced by using HEPA filtration in the areas where cell cultures are manipulated and incubated. And this can also greatly reduce the risk of cross-contamination between different types of culture.
All Whitley HEPA workstations are fitted with our unique Whitley internal HEPA filtration system. The atmosphere in those workstations passes through the filters hundreds of times an hour. This ensures that the atmosphere is cleaned quickly and efficiently and remains clean. There's also a laminar flow-like effect caused as the atmosphere passes through the filter. We've worked with one of the world's leading filter manufacturers to create a filter that is bespoke to our requirements. We place the filter inside the workstation. This ensures it remains dry, can never attract moisture and never become saturated. To show you just how efficient our system is, we'll now go through a simple and brief demonstration. One of the scientists in our in-house laboratories has been conducting work in a Whitley H35 hypoxy station. Normal laboratory background levels of particulate are high. Once the workstation is closed up and sealed, after sampling just 2 cubic feet of atmosphere inside the workstation, observe how low the particulate count has become. You can see by the counter that on entering the workstation, particulate is introduced. However, if you keep an eye on the counter, as the HEPA filter starts to work immediately, and don't forget that all the atmosphere is recirculated and passes through the filter continuously hundreds of times an hour, you can see that the particulate count is soon reduced to 0.
The ISO 14644 standard addresses particle counts, but we also wanted to specifically demonstrate the removal of bacteria from the atmosphere of our HEPA workstations. So in our laboratory, we conducted tests with aerosolized bacterial cells and spores and quantified their removal. We tested various workstations, including a non-HEPA model, to provide a comparison. We used non-spore-forming and spore-forming bacteria, which were prepared as dense suspensions and aerosolized into the internal atmosphere of each workstation using a nebulizer. Bacteria remaining within the atmosphere were then collected at intervals using an air sampler. In a HEPA workstation, within 2 minutes after completion of nebulization, the viable bacterial count was reduced more than 100-fold in comparison with the equivalent non-HEPA model, and within 5 minutes the organism was no longer recovered. These results correlate with the particle count data and demonstrate that the required level of atmospheric cleanliness is regained well within the 20 minutes set out in the standard. If you wish to read more about these tests, a copy of the technical note HE04 is available on our website. Some users of Whitley workstations require additional safeguards to reduce the possibility of bacteria within the chamber being released via the gas outlets. There are two gas outlets on Whitley workstations, the main chamber exhaust valve and the interlock exhaust valve. To address this requirement, our HEPA workstations can be specified with additional HEPA filtration fitted to the exhaust valves. We conducted laboratory tests to challenge these filters with high concentrations of aerosolized bacteria and quantify the release of these bacteria through the valves. For testing purposes only, we used a standard H35 workstation without internal HEPA filtration so that bacteria could not be removed from the internal atmosphere before it was discharged through the valves. We prepared a dense bacterial suspension and aerosolized this into the chamber atmosphere using a nebulizer. For this test, the inner interlock door was left open so that bacteria could enter the interlock. We forced the internal atmosphere to be discharged from the chamber, first through the main exhaust valve and then through the interlock exhaust valve. Using an air sampler, we collected 100 litre samples of discharged gas from each of these valves onto agar plates. Based on the number of bacteria aerosolized within the chamber, the volume of gas released through the valves and the number of colonies recovered, we can calculate that there was a reduction in bacterial numbers of more than 99.999% compared with the number that would be released in the absence of a filter. Based on these results, we've introduced the Whitley Enhanced Biological Containment System as an option for all our HEPA workstations.